Okay, a couple more limits to look at, and again, we're going to be doing these limits by tables. Okay, so first of all, something you might remember in the last example, we looked at the limit as x approaches 2 of x squared plus 1, and we got that this limit was 5, which just so happens to be what you would get by putting 2 in for x. 2 squared plus 1 is 5. Well, I put these two new examples up because I want to show you that that doesn't always happen. You can't always just put this number into the function to get the limit. Okay, and a couple good examples here to kind of illustrate why that's the case. Okay, so here, first of all, we have the limit as x approaches 1 of x squared minus 1 over x minus 1. Okay, now we can't put 1 in to answer this limit because when we do that, we get 1 squared minus 1, which is 0, over 1 minus 1, which is 0. Okay, this expression doesn't even make sense when x is 1. So certainly it's not going to be the same thing as putting 1 in for x. Now what's surprising about this, even though putting 1 in for x gives us nonsense, 0 divided by 0 in math is just undefined. It's nothing. It's not a number. It's not anything else. So what's surprising is that there is a limit here, and it's not something strange. It's a pretty normal number. So again, to answer the question of the limit, we put numbers that are getting close to 1 from the left and from the right, and see what we get. Okay, so we made two tables here again. We get some numbers which are getting close to 1 from the left. So numbers which are getting closer and closer to 1 from the smaller side. So I'm putting numbers like 0.9, 0.99, 0.999 in for x. And look what the function value is coming out. 1.9, 1.99, 1.999. Okay, so as I pick numbers closer to 1 from the left side, I get numbers out which are closer to 2, as you can see from the table. Okay, getting very close to 2 here. And similarly, from the other side, the side to the right of 1, if I put numbers that are just a little bit bigger than 1 into this function for x, I get numbers which come out and are getting closer and closer to 2, this time on the bigger side. Look at this, 1.1, 1.01, 1.001. I'm picking numbers which are getting close to x from the, getting close to 1 from the right side, a little bit bigger than 1. And the numbers I get out get closer and closer to 2 yet again. Okay, so since both of these tables seem to indicate that the function is getting close to 2, we can go ahead and say that that's the limit. And definitely nothing you could find out just by glancing at this function. You have to construct the table to see that the limit is 2. Okay. Now over here we got a different case. Okay, so similarly, we're asking here, by the way, the limit as x approaches 0 of the absolute value of x over x. Okay, and again, we can't put 0 in for x directly. We know that's not going to be the right answer because we'll divide by 0, which is undefined. Okay. Now, if I make a table here, again, it's very similar to the last one, but look at my table here. Okay, I'm putting numbers that are getting closer to 0 in for x right here from the left side. So numbers that are just to the left of 0, as an example, negative 0.1, okay, negative 0.01, even closer to 0, and negative 0.001. Okay. Now, this is a very simple fraction. It's the absolute value of x divided by x. Okay. So when I put negative numbers in here, it turns out I always get negative 1 out because, look, these two numbers are going to be the same, but this one's going to be positive and this one's going to be negative since I'm putting negative numbers in for x. Right? The absolute value just makes things positive. So in this case, every time I get negative 1 out of the function. Okay? So certainly on this side, the function's approaching negative 1. Okay? Let's look on the other side. Okay? When x is getting closer to 0 from the right, look at what happens. When I put 0.1 in for x, I get the absolute value of 0.1 divided by 0.1. Well, those are both 0.1, so divide those and I get positive 1. And again, no matter what positive number I put in for x, I'm always going to get 1 out of the function. Okay? So these two limits are different. Okay? They're not the same number. From the left we get one thing, from the right we get something else. Okay? That happens. Now when that happens, we can just say the limit is either undefined or it does not exist. Okay? You might even write DNE for short. Okay. Now, one last thing with this, again, it's in the notes, but we can rule out, or we can say something a little bit different in the case of this limit. The limit from the left existed, the limit from the right existed, but they're not the same thing. So, for instance, what we could say is the limit as x approaches 0 from the left, the little minus sign up here, of the absolute value of x over x. Okay, that was negative 1. Okay, this little minus sign above the limit point means from the left only. Okay, so that limit was negative 1. However, when we look at x values getting close to 0 from the positive side, the right side, we got something different. We got positive 1. Okay. So the limit from one side was -1, the limit from the other side was +1, but overall, the limit doesn't exist.